Hello and welcome. Today in the morning we will have a short session about introduction to GitHub, but mostly talking about version control. And I will start a little bit introducing myself. I can use the pointer. Wait, I will set this up so I don't have to walk to the computer. So, hello. I am assistant professor at Charles University, specifically at the Faculty of Science. So by training, I'm quantitative ecologist. I work with plants, with databases and plants. And I'm mostly focusing on like large-scale biodiversity. So how, for example, species richness is changing, if it's in space and in time, specifically to relationship to modern crises like climate change, etc. Yeah, and I have my own lab with students, which is called Laboratory Quantitative Ecology. And these are various places where you can find me. I have to say, I am not a computer scientist. Right? I didn't learn this. Everything which I'm showing you is something I learned myself. Right? So if you are more into this stuff, maybe you can find different opinions about stuff. So I said something about myself. It will be cool to find out something about you. So we will do short raising your hands to just let me know. I send a questionnaire, but still I would be like to know who is in the room. So can you raise your hand if you're using Windows? Just to make... Okay, and the rest is using Linux, I guess, Unix? Okay, 2 people, cool. And then I try to tailor it to your catering. So I will be showing everything on Windows. I have a Windows machine, and I will be showing everything using software called GitHub Desktop. I will show you in a moment. But for those who are familiar or comfortable with using terminal or shell or what you're using, there will be also ways how to do it in this, right? All of these things can be done by various software. I will be showing parts of that, and parts of that you will be seeing in the presentation. Speaking of the presentation is right now publicly available. You can go, is this working? Oh my God, that's weird. So you can go to bit.ly/model_press_su if you want. I will, in a moment, I will also show you how to actually find it on GitHub yourself, because that's publicly available. Okay, so what are we actually going to be talking today? We're going to be talking about what is version control, how to set it up on your machine. Hopefully you already done most of the parts. How to record a change, how to make a commit, how to sync your local computer with the server, with the remote, and how you can collaborate with other researchers on the projects together using branches and other parts of these version control tools. Purokas, that's kind of part of it. So by the end, hopefully you will understand what is Git and some basic terminology. You will be able to create GitHub repo. You will be able to make a commit and push and pull changes, and handle merge conflicts, make branches, etc. So, So if any of these words are unknown to you, that's fine. That's why we are here. I will try to teach you. So I will start a little bit broad, about open research in general, because version controlling, in my view, it's part of open research, about reproducible, etc. This is something which I'm also teaching at the university to the students. And I think, I will try to do the mouse again, which is kind of scary. So lots of people about open research are here, right? And then we're slowly getting on this gradient to more. So maybe we are, hopefully this will be similar here in this lecture. This is very weird. What is going on, and hopefully you will find out it's nothing scary, and you will be starting using it yourself. So open science in general is a big topic, right? Which goes about open scientific knowledge, infrastructures, dialogue with the environment, and I think somewhere. But I like this, a better view about what open science is, right? And here we can talk about open access, open data, open reproducible research. That's what I am mostly interested in. Open science evaluation, etc., right? This is kind of break down what it is. And version control is part of that, I would say, mostly part of the reproducibility research, but not only. So mostly it is a journey for everyone, right? Everyone in this room is somewhere on this journey. And hopefully we are starting with sharing our data, sharing the tools we are using, sharing the code we are maybe writing, and sharing the results. So this will be the thing which we can share, hopefully, when we are doing research. Most of you are researchers based on the questionnaire I did. Quick, maybe again, raising your hand. Have you ever, who is a researcher? Who is an active researcher? Raise your hand. Do we have any PhD students? Okay, well, okay, researchers, PhD students, okay, I agree. And then who is writing code? Okay, cool. That will be much easier. So who is sharing their code with their papers? Few people, cool. And you will learn how to do it very easily today. Okay, so version control. Let's talk about that. I included this, I think, cool topic, which this is mostly for students, but I think lots of us are familiar with this. When we are writing a paper or document, we have the final version, right? We give it for comments to either supervisor or collaborators, and then it's final review 2, final review 6 comments, final, etc., right? I think we all kind of know, sadly, this pain, but there are now better ways how to do it. So what is version control? Version control, in the end, is keeping track of the changes we are doing, right? That's in the end, that's the only thing which it is. We are keeping a track of the changes, and that's the keeping track and changes are the two keywords which we're going to be hearing a lot today. So I'm going to do a quick exercise. You are separated a lot. I don't like that. I would like if people actually talk with each other. So talk either, turn to your left or to your right. And can you do a short discussion among yourself if you do recognize these questions and what kind of system of keeping track of changes are you actually using? And we will have 3 minutes. Go ahead, and I will walk by the room and listen what you're talking. You can either talk here or go back, etc. I'll turn this off because that's scary. Okay, I will turn this back on. Thank you very much. It was a cool discussion. It's a little bit more lively again. So I've heard when I walked and I discussed a little bit, I've heard some topics which kind of get common. Some of you, I was very surprised, some of you actually are familiar with some version control or Git and using, for example, GitHub, so they just want to learn more. Some of them never done this, are very beginners, even struggle with setting everything by my guidance. We will go through it again, don't worry. And regarding questions, like some people are saving their data, somewhere else. They can use a flash or external drive maybe, or they're backing up on a server like OneDrive, etc. I will show you a way how to do it differently, how you can use the GitHub, which makes a little bit more sense because you will have a little bit better control about the changes you are doing. Okay, so let's talk about some, I call it fundamentals. This is something not about version control, but in general, it's a good thing to do when you're doing reproducibility research, is self-containment. And mostly we're talking about papers, since you're researchers. And so each paper is a single project, meaning we should put everything to a one folder, right? In your computer, it could be folder, and the specific project should contain data, code, notes, documentation, anything related to that should be in a one folder, right? That's called self-containment, and that's a generally good practice to do. Overall, this is important. This is important for the version control because the software, the Git, is understanding folder structure within your project and understand that this project specifically is linked to this GitHub repo, etc. So I will not talk about this in detail, but in general, there is a way how you should structure your project, right? And it could be data, analysis, results, some README, etc. There are various things which you should normally follow these guidelines, and you can look them online or ask ChatGPT if you want about what are some good practices to follow when you're structuring your own project folder structure. So, some basic terms, again. We have two main things which we're going to be talking today. One of them on the left is Git, and on the right is GitHub. Git is a local software in your computer. Hopefully you have all installed it. We will see. And his main task is to keep track of changes. I like to imagine that it's a small, tiny man who is sitting in my computer and watching a file. And if the file changes, if you notice something change, he will notify me, and he will see how this works. But this is my mental image, how the Git software works. It's a tiny man watching changes. And that GitHub, that's a server, right? It's any other server. It's hosting data. Mostly it's hosting your Git data. But there are other ways you can use GitHub. which is for project management, collaboration, publishing. We will talk about it a little bit about the collaboration part today, because sadly we don't have much more time. But that's a server. I have to say, we are going to be using GitHub, but theoretically, for lots of these things, you can use other different servers. There is GitLab, which is a concurrent. There is also, you can ask your IT department to start your own server here, for example, locally, which you can use instead of GitHub. So if you don't like Microsoft, and you have something, again, if you don't want your data to be used to be trained by LLM, and they do, every data on GitHub is used to train LLM, you can use somewhere else. But for the convenience, I will be showing everything on GitHub, because I use it every day, and I think it's easy to follow, and it's a nice tool, which is also for free. So, setting everything up, I call it the Git hell, because it is a tricky. Hopefully, you have followed these instructions about everything, which you currently need to have a Git. Raise your hand if you have GitHub account. Perfect. Raise your hand if you install Git, the software. And raise your hand if you have GitHub desktop. If not, that will be cool to install, because I will be showing a lot of things in the GitHub desktop, and I will talk about it a little bit later. So I call it web.shop, or GUI, as they call it, it's graphical user interface. That's a software which helps you visualize what you do. Of course, you can still use shell or terminal or whatever, and there will be, but I will be, because I like visual things, I like to see how things are. I'm a very visually oriented person. I will be showing you everything mainly in GitHub desktop. If you're using something else like VS Code or something else, there will be ways how to do it also in the presentation, and you can click through. Okay. So some basic vocabulary. I need to be checking time. Cool. A script, which I generally assume we all are producing scripts. We are kind of programmers or data analysts or something like that. Script is a record of a code, which is a instruction for computers to do something. A project is a self-contained study paper, whatever you want to say, which has the script, the data, figures, outputs, configuration, whatever you need. Such a project in version control world is called repository, or short repo. Right, so we'll call it a repo, which, what does this mean? It's a folder which is holding all information about specific project. If this repo is locally, meaning on your computer, it's called local, right? It's on your machine. If it's on the same project can be also stored somewhere else, on the server. If that's online, somewhere on the cloud. If it's that, we call it a remote. Yeah, I think there's a small thing. So local repository, that's your computer, remote. In our case, in these examples, I will be using GitHub for now. You can use, theoretically, some other servers. Okay, is this clear? Yeah? Cool. Okay, note on practical exercises. So I like to do things in a way, I call it monkey see, monkey do. I will show you how I do the thing. In the time, you will be not touching computers. And then you will have time to practice yourself. Okay, so first you will watch me do it, and then you will do it. So we will create a new repo on our local computer, right? So we need to make sure that the Git, the software, which you hopefully have installed, knows that it's supposed to be watching this specific project, right? We are trying to initiate the Git software in a specific project. I will show you with the presentation how this works. So as I told you, the mouse, hello. No. Is this uncomfortable with this one? Okay, I can't use it. Okay, weird. So I will show you quickly how to get the presentation, but if you want to use, so here there are kind of tabs which you can click in the presentation. So there is always, for GitHub, that's the default one which I will be showing, but if you want to use, if you're using VS Code, there's always tab for VS Code. If you want to use shell or command line, there will be tab for that also. So I'll just quickly show you how to do it. So I will alt tab to GitHub desktop. I open GitHub desktop, and there's various things what we can do. We can create new repository on your local drive, which means I will create a folder which will be for the specific project, or I can add existing repository, right? Which means there are some you can see here, some set up from previous things, but I will show you how to do it. create new repository in your local drive. Very simple. We call it awesome project, as always. We can do description, where it's going to be located. I will be located on my computer. And don't worry, you can initiate with README, etc. There are various things which we are not going to talk about, but we just create repository. And now we can see here in the GitHub desktop that I am currently an awesome project, and there are no local changes. I can also very simply show an explorer, which will open the folder. I'll make it bigger. In my explorer, so I'm using Windows machine as I told you. So I'm this project FZU, an awesome project. There's nothing in it, right? We can see, we can know that it has GitHub. Sorry, it has Git initiated because there is this .git folder there, and I can also see it in my GitHub that I'm on this project. Okay. Now, make a new project with Git tracking. Cool. In the meantime, some people were very quick. This is very good. I will show you how to get to the presentation, maybe one more time, because I didn't show it. So if we open any browser, we will go to github.com. I sign out so you can see exactly what as you would do. You should sign in if you have the account, hopefully. But you can just search my name, which is Andre, M-O-T-T-L. This is me. And you can search for users. That's me. I'll make it bigger. Boop. Right? And now we need to navigate to my repositories, which are the repos, as we discussed. And the first one is version control, this one, right? Which you're doing here. And here, you can see on the right side, there will be a link which you can click. I will open a new tab. And that's the presentation. And you use arrows to navigate. I will repeat again. If you find me, go to repositories, click on the first one, and here on the right, there is a link to the presentation. Yes? It's fine for everyone? Does anyone need a little bit more time with is it okay with the init? Have we started, hopefully, a folder which is now having the Git initiated? Okay. Okay. So, I need to now switch the mouse again. And now I will be walking to my keyboard. Okay. So, but this will not work, right? Okay. Weird. Okay, so let's talk about a commit. A commit is a new word for lots of you. A commit is a record of a change, right? You need to write down what we have changed. If you need to create or edit a file in your repo and save the changes, you need to record the change via commit, right? So if you change something, you save it on your computer. The computer knows that it's safe, but you now need to record that you changed something. It's kind of weird. It's a little bit difficult maybe to realize, but I found out, I think, a good analogy to do this. Right? So raise your hand if you see Queen's Gambit on Netflix. Okay, raise your hand if you play chess. Few people chess. Okay, so in chess, for those who don't know, in chess, there's something called chess diary or chess move diary, and it was seen in the TV series. And basically, when they move a figure, I don't know how we call it, a figure, then you will write down something on a paper. And you write, for example, I move bishop to c4. I don't know if this is real, I just made this up. But they will write this bc4 and nf3 and q, and you will write down on a piece of paper, one by one, what you're doing, what the opponent is doing. So you're recording, you're writing down, you're recording the changes happening to the board. Right? This is kind of a similar thing. We need to write down what happened to the board. We can move a piece and we write down the record, what happened from the last moment of the board. And this is a history of changes which happened to the board, to the chessboard. Okay? So that's kind of similar. In computer, we can do the same. So if we moved a pawn to d4, we write down pawn to d4 or pd4. It's the same with computers. We can write down I edited a line 32 of file A. That's the same thing. I can write this down on a piece of paper. This will be very ineffective. But we have now software which will do it nicely for us. And how to read this? We have a state of a project, which is this bubble. You will be seeing these bubbles a lot. And then we change the state to something new because we edited a file. And we record that. We write down, oh, we edited file A by changing line 32. And we write it down, and this record, this written down, it's called a commit. So we have original state, and we added a new commit. You see C1, commit 1. We can now chain these, right? This is similar with the chest. We edited this file, then we edited this file, another file, sorry, and then we maybe delete a file. And each of these bubbles, we're slowly recording changes we've done to the whole project. Maybe, hopefully, it's a little bit clear. We will see it in action. It makes much more sense. So each file in a project, in a repo, can have several stages. This is very small. I like this visualization, which the file can be modified, meaning it is different from the last recorded stage, right? If there is an empty file and I write something in the file, now I modify the file because it's different from the last recorded one. I can stage it, which I like this drawing. That's putting the changes from different files to a palette. You can stage changes from different files together. And then when we commit, that's when we write down, oh, we actually changed these files. We put them in this truck and then leave it away. Right? So we modified files, and these can be just small boxes. We added some files of code. We write some documentation. Maybe we really deleted some unwanted files. These files are modified. We need to stage them to put them together on a palette, right? These are staged. And then we will commit, we will ship them away, right? We will write them down. Okay, how this looks, again, in a VS Code or in some of the other things is actually very simple. In a GitHub desktop, on the side, I will show it in practice, we see these ways. This is on changes which happen to the files. And they can have either green, yellow, or red. The red icons suggest that this file has been removed since the last time. The yellow is that it's modified, and the green, it's a new. Right? In VS Code, it's very similar. That you will see them. There's M, like modified, A by add, etc. You can also see them in command line by list. But you can stage them, meaning putting the change in a palette by clicking these buttons here, and I will show you how to do it. Where's my keyboard? Here. So if you go to a project, I'm in my awesome project. You can see it up. Is it too small? Can I make it bigger? View, zoom in. Can you see okay? Is this fine? Should I zoom more? This should be enough. Is this fine? Yeah? Okay. I will now jump to my awesome project. And I will create a new, let's say, tax document. And I call it data, right? For example. And now, if we jump to the, don't touch your keyboards. I will let you, please. Okay. So you will have time to do it by yourself, don't worry. So if I create a new file and I look into the GitHub, immediately you see that there is a change, right? Since the last time, the small man, again, the small tiny dwarf in my computer noticed something is new, right? Something changed. There's a new file, which will data X, and I can stage it. If I click on this, this is staged, right? I can switch to more, don't worry about this. I can switch to more, no, I deleted. No. So I will switch to a different project so I can do a little bit more. So I switched to a project which actually have more files, so we can do a little bit more. There are many files, right? It's already a big project. And I can, I don't know, go into a license, edit it with as a notepad, and I can add something here. important message. Like there will be typos, don't worry. And if I open it again, it noticed that something changed, right? That the file license specifically has added some lines, and you can immediately see on the side that it's added. I will also delete something so you can see how things happen. So I can sorry. I will delete this color palette, and if I go back to GitHub, it will notice, oh, this is deleted. It's minus, right? So this is a deleted file, right? So it noticed something have, and I can now stage them. The staging is very simple. I can click which of these goes to the palette. Staging is the preparing things to the palette. So I'm staging it. I'm clicking these ticks, making it to the palette. So this seems simple, but I think it's good practicing. So now, make changes to a file in your repo, make a new file, stage and unstage changes. Try playing with this. And I will walk around again and help you if needed. Excellent question. So I know there are quite a lot of questions. There was a good question. So maybe you noticed, you created a file, the Git notes about it, but when you delete it, it was not there, right? And that's kind of weird. And the reason for that, because it's only comparing the project to the last recorded version. The file you created was not yet recorded, so the small man doesn't know it should be there, so it doesn't know it's removed, right? So it's comparing to the last stage of the project, and in the last project, this file was not found, so it didn't know it was deleted. Okay, there were more questions? Turn this on? Okay, so there was again question, what does it mean stage, unstage? It's just putting these modified files together on a palette or not, and take it away. Right? We haven't recorded anything, but it was a good practice. Now will be the main thing which we need to record the changes. Right? This is the big thing, which is making a commit. Again, don't touch your computers. I will first show it, then you will do it. It's very simple in GitHub. I will switch back to my test project, and I will stage it. Right, staged now. You need to write a description. I think you have it there. Okay. Sorry, I need to check. Okay. We need to write a description, which you describe what the changes is. I added a data file. Right? You need to have it. No, sorry, it's here. This is a commit message that's on the top. And here, if you need, you can describe more. Right? You can blah, blah, blah. You can do whatever, how long. This can be pretty long, right? If you need very detailed things, if you changed a lot of things. These messages are important, we will talk about it. So I added the data file, and here I will press commit 1 to the main. Boop. And now it's gone, right? I don't see any more changes, even though the data is here. Why is it so small, right? Now I can go into the data. I will species 1, as an ecologist, I will save. That's important. I need to save the file, so it's modified on my computer. I will go back to GitHub, and now, oh, there is something new. The change you recorded previously has a change. What I can also do, I can delete that file, right? So if I close this one, if I deleted one, and I go back, oh, it's minus. It's missing, because it's comparing to the last recorded change. Right? We will practice it. One more thing which I want to show is a history. Right? We can now go back to this history and talk about the changes. Right? It will be in a chronological order. The individual commits are here on the left. Here is the initial commit, which is the one which is automatically added to your repo when you initiate it. It will be automatically recorded. It's the first commit, and that's the stage which all the future your next changes will be compared to. There's also one more commit which I added. I added the data just for practice. I will do some more. As a project, I will do new text document. How to make a bike, and we will buy a bike. We'll make it bigger. Okay, save. And I will commit. I don't want to commit the data, deletion of the data, right? I can select what am I staging, what am I putting to the palette. I don't want to record the change about the data. I just want to record the change about the new text file, and we code it. Create how to make it, yeah? description of bike. I don't know, right? They're always same. Commit. And again, if you go back to the history, I see initial commit, add a data file, a description from bike. I can see these changes. What we can also see here is the description I wrote down. Who did this? It was me. And what happened? What are all the changes? If we change more files, which you can, again, I will switch to a bigger project so you can see it. If we change more files, they will be all here, and I can click on them, and this will be all the things which I changed in this massive commit, right? And I can look at it, right? And here on top there's some summary values. This how much was added, how much was deleted. If you are using, you can also in a command line git stat log. It's the same thing. It will be unique identification, which is the SHA. Who did this? Author. When was this done? Message and stat what changes. It's exactly the same thing are visualized here in the GitHub, right? And it's just I think nicer, right? I prefer to work with this. Okay. Now your time. Commit some changes, review history, and again I will walk amongst you to help you. Excellent question. I will say it aloud. So the question was, if you delete a file and the Git knows that you delete it, can you then save it? Yes. That's the big advantage of Git in overall. You will never lose anything. If you do it correctly, if you're committing often, we will talk about it, you can't lose files ever, right? Because you recorded the changes and we can revert these changes and we'll show you how to do this. Are we done? Have you managed to commit changes, hopefully? Let's see. Okay. So, about some commit messages, right? Commits are cheap in terms of you can make them quickly, they don't cost you time, they don't cost you mental energy. My suggestion is commit often, really often, right? Because lots of people, they will work all day, and by the end of the day, they changed 200 files, million lines, and they found that, oh, I haven't committed anything, right? I would recommend commit often and provide useful commit messages. And the commit messages are to your future self, and you will thank them. I like this comic. Again, as the project drags on, my commit messages get less and less informative. This is, first created main loop, timing control, enable config, and then more code. Here are some code. My hands are typing, blah, blah, blah. Right? So these are not very good commit messages, because if you open this project in 5 years, on 10 years, you will have no idea what you've done. Right? So it's a very good practice to, it's a very good practice to try, take your time, write it. I think nowadays, in, for example, VS Code, or maybe in the GitHub desktop, I'm not sure, the AI will do it for you. It's even cheaper, right? They will find out what you've changed it and suggested the commit messages for you. But overall, you know best what you've done. And remember, it's for your future self. You will thank yourself very, very much if you actually write them informative. Okay, about the commit history, it's kind of, my head will be killing me tomorrow. About the commit history, so again, this is the same thing with the bubbles. We have a commit A, B, etc., and this is the timeline. We call one of them a commit, which is the record of a change. Difference between two commits, it's called diff. Call it diff. This is what change from one point of the project to the next one is a diff. You can do diff between next to each other. You can also do diffs between somewhere else, right? What change in long term. The commits, again, they will have some unique identification. It is called SHA, I think, and some messages, right? This is the commit messages, and this is a different commit, and this is a different commit. And now, this is where we are currently. This is our current world. This is the current state of the project. Okay, I suggest we do 5 minutes break for, do we need a break? Do we need a break? Yeah? Yeah, okay, let's do 5 minutes. Let's go toilet, stretch out, run some stairs so you're active again. And we will meet in 5 minutes. Okay, hopefully you're refreshed. You're good to go. Sorry, I'm a little bit time concerned. So we will talk to the next things. Hopefully you now know what is commit, what is staging, what is repo, etc. And now we will talk about the remote. If you remember correctly, remote, we called the repo, the project, which is up in the cloud, right? That's on the server. So I have this nice visualization. And what we have been done right now, we have this local computer, that's your laptop. In this case, it's Kingsley laptop. It's a local repo. We developed some code. He committed his to the local, right? This is what we've been doing. We developed the code, we committed, and now we need to know the important part. We need to put it up to the server. In the blue is always the remote. So this is, we need to push. If you're going up to the cloud, we are pushing up, okay? So we need to push it up so the same project is duplicated then on both your local and your remote. You will have the same copy recorded there. Okay. I think I will also open VS Code so you can see what I'm doing. But it's very simple. If you don't have remote, if you never put anything, it's called publishing. Publish a branch or publish a repo. It will be a button. If you already have one, if he knows, he will know that there is a repo. He will push. You're just pushing changes. And again, this is, I will show it in GitHub desktop, but I need to take this out. Weird. In VS Code, it's exactly the same. You use the panel in command line. It's remote add origin. You need to add the remote, and then you're pushing. So I will show it now in the GitHub desktop. I will switch back to the project. So here on the right, if you're using GitHub desktop, it's a big button called Publish Repository. I will click it. It will ask me, oh, how do you want to name the project? It's a good practice to name it the same. Keep the name same on your local and thing. So it will ask to keep it private. I will say no. I will make it public. I don't care. And publish. Boop. And now we can somewhere view. There's a way to do this. So if I now, I will do it this way. If I now go into my GitHub, into my repositories, I can see awesome project there because I pushed it up. And if I open it, I can see that it's the same. The data is there, how to ride the bike or whatever you say. All the files are same there. If I now delete this data, and I will delete data.txt, I will commit. So I can see there is a new commit which is delete data, which is not on the remote. You will see it here on the right that there is one, meaning we are one commit ahead. We need to push this commit, push up, and it's there. So the files should be gone. If you go back to the GitHub, the data is deleted. It's gone, right? The same information should be on a GitHub and on your local, including the history, right? So here, kind of hidden on GitHub. We will show the GitHub a little bit more later. But here is the clock, which is the history. And I can see the commits. It's the same information, and it's your GitHub desktop. Exactly the same. In the VS Code, I will open VS Code because there are some people. Code. Oh, this is some other project. And I will open a folder. I will jump to this one, for example. Yeah, yes, I think it will do all the things. It's exactly the same. I can remember we deleted the license. I will delete the palette. I will delete color palette. It's the same. If my keyboard works, maybe. Delete palette. How do you spell palette? Like this. And I will sync changes, which is pushing up. Right? It's the same thing. It's exactly the same as in this one. So back to the presentation. Where it is? There. No, not this one. This one. I think your time, publish a repo to GitHub, make a new commit, push the changes to remote. And again, I will walk amongst you to help you if you need. No? Hello, hello? Okay. Works again. Okay. Different people using different softwares. It's tricky to do, but hopefully we're doing fine. I'll try to use keyboard. Okay. So now it could happen. I need to put this in. That several people, several different machines, it could be you on different machines, it could be different people, can be actually connected to the same repo, right, on GitHub. Right? That's generally if you work, for example, with colleagues or use different machines, right? I have several computers actually, in each office I have different one. Then what can happen is, for example, here Chan can push to remote, but now Maria will not have these changes. What Maria needs to do, she needs to update the version on her computer, and that's called pull. So we're pushing up, we're pulling down, okay? Here is the same thing, but again, the same differently. Here we know Kingsley, he has his own computer, he's developing a code, he will commit, he will record the messages, and then he will push them up. Whee! Now it's in the remote. Now Angelina, his friend, she will pull down from the changes. She can develop code, commit, and push, and forever, right? So this is pushing up, pulling down. Okay, it's very simple. Again, in the GitHub, there is the same button for pushing will be pulling. You will see in VS Code it's the same. You will know that you need to sync the changes. On command line, it's git pull. Right? It's not complicated. It's a little bit difficult for me to now show you how this works because I don't have a different computer to connect to this one. What I am going to do instead, and this is something you can also do, I will go into my GitHub, and here, this is kind of recent change. GitHub also allows to edit things directly there. Right? So you don't have to actually open it on your computer. You can edit the remote way because this is on the server. For example, if I go to this file, I can now edit. No, I'm not signing in. I see. I need to sign in. Sorry, but you need to do this as well, I guess. Boop. Approve, and I'm in. Okay. So if I'm signed in, as you should be, and I'm in my repo, I can now go to a file and actually click here, edit file. You can actually editing file directly online, which is something useful if you don't have your computer, or if you just want to show something quickly. I will add a new line. Very original. Buy a bike. No, we will figure this out. Repair a bike, right? So it's in team. Repair a bike. And now I will commit changes, as always. And he will actually think about it. The AI will do it for me. And now, so now, if I go to my awesome thing, I will have to fetch. Fetching is something we haven't discussed. It normally do automatically, but fetching is figuring out what's happening on the cloud because it's not updating, it's kind of update or refresh, right? It's called fetching. And now it knows on top right that origin, there is one from arrow down, there is one commit above which I need to pull down, right? So I can click, and now if I open the file on my local, if I go to how to make a bike, repair bike is there, right? So it will be the similar thing if someone had edited, I need to pull it down on my computer. And since this is not very easy to demonstrate, we will not do that, we will not test it, but I will do something instead. I will do GitHub intermezzo, I call it, which is, we talk a lot about GitHub, about the website, but actually I haven't shown you what is on GitHub, right? How the GitHub looks, what is there, what's the information, how to use it, and I will use the time now to do so. So a GitHub repo, this is how it is, right? Hopefully you see it. It will be mostly, the key things are that there is a, no, I need to put it in. Oh, God damn it. A little bit annoying. You can see who is this owner. This will be mostly you, but it could be someone else, right? This is Kingsley. Again, we talk about Kingsley. This is his, Kingsley Shacklebolt, and his dragon study. Do you know who Kingsley Shacklebolt is, by the way? Any nerds? No, it's from Harry Potter. It doesn't matter. And he's studying dragons, so it's dragon study. Here we can see the files, as you normally do. There is git ignore and readme file. They're just 2 files. And automatically, if you include readme file into your repo, the GitHub will show it here. So it will render it. So this is very good. If someone stumble upon, on your repo, you can write down what is this about, right? So this is kind of a good practice. That's why readmes are very important. And we can also see branches. We will talk about it. And there are commits. There is 1 commit right now, and we've seen how the history is. I will again show it now in practice here. So it's under my name. It's awesome project. It's public. That could be public or private. We'll talk about it a little bit. And they are just 2 files. You can click on them if you want. It will open the file. It will also, here is the history, where you can see the commits. And we can click on the commit. And it will show you all the information about the commit as we've seen already previously. Right? So this is actually the interface for GitHub Online is very nice. So now we will actually do what you can do is you can also create a new repo online first. So we see first create, following on offline on your local and then pushing it up. You can do the other way around. You can create first online repo first and then put it down. Right? So how this is done, it's very simple. There's this green button new, which is everywhere. Then you need to choose who is the owner. Mostly it will be just you. But if you are, for example, part of organization, which we are not going to discuss today, you may have something else. Then you will name the repo. It will check if actually it's a valid name. So names cannot have spaces between them. You need to do underscores or dashes. Then you can choose if it's private or public. So we see this a little bit. Public ones, anyone on the internet can see it. Can't do anything with it. Can't edit the files, but can see it and can download your files. If it's private, no one can see it. Right? So by default, if you're not paying GitHub, you can create private ones, but the functionality within private repos will be restricted. Right? So that's why this is the little bit downside. Why they want everything publicly available. Yes?
Can you change it?
Yes, I will show. I will show how to do it. You can also, when you're creating, you can set up a few things which have been mentioned. README, which is a description of the project. Git ignore, which is, this is a little bit advanced, but it's kind of this a list of files which should be ignored by Git. Right? So for example, you can imagine you have a little folder which will have some private data, patient data. So you don't ever want to do this online. So you will add this file to your git ignore, and Git will not look into these changes. They can be happening changes, and he's ignoring them. Git ignore. He's ignoring the changes. That's why it's git ignore. License. It's also very good to do. Tell others what they can do with your code. So README is telling others what this is about. License is what they can do. It's MIT license, CC, BI. I don't know what you're using. If you don't know what these are, contact your librarians or data administrators or something at your institution. There should be someone who should explain to you how licensing works. But in general, lots of them will be by default open, like MIT. Right, so if you fill this all in, the name, it's public, we don't want to create any README anything, it's just a fun thing. We create repository and it will be there. I will be showing first how to do this again, and then you will have time, don't worry. So if we go to GitHub, you can either, if you are in your this is also, if you click on your name, this will be your profile. You can actually add some information here. I have some information. You will find your repositories, which are the individual repos, and you can open them. Here is already the new button there, which you can create a new thing under your repositories. Or anywhere you are, there will be always this plus button on top. Anywhere you are on GitHub, and you can create a new repository. Right? We'll go into this one, this green button path, new, again, general. Who is the owner? Because I am owner also of lots of different projects, so I have things to choose. You will just see your name. I will call this plan to take over the world, obviously. And it will automatically set, oh, you can't have spaces. It will rename it for me using dashes. That's fine. I will make this private because we don't want anyone to see this plan, how to take over the world, right? That's a very private thing. We can add readme, add git ignore. It's based on what you're doing. If you're using Python, I think it will be, if you're using Python, it will automatically git ignore lots of Python stuff which shouldn't be there. Licenses, we will do MIT, let's say. And I will create. Bam. Now, actually, oh, the repo is there. If I go into my repos, it will be there, plan to take over the world. Right? There is nothing in it. It's just readme, licenses, git ignore. I can do things. But there was a question, which I will show now. OK, how do we make things private or public? Right? And that's a good question. You need to go into settings. If you have it not zoom in, there will be settings button. And then general, and you need to scroll way down. I will not talk about most of them. And there is a danger zone. They call it the danger zone, which I like. Here you can change visibility. That goes from public to private and vice versa. You can also delete this repo. Right? So, but it will ask you like a million times if you're really, really, really sure you want to do this, because deleting from GitHub, if you don't have it locally stored, it's gone forever, including all the things, everything. OK. Create a, oh, I actually have. So I will delete this now. Delete. Yes, I understand. You need to now copy the name to make sure that you are thinking about what you're doing. Bam, and it's gone, right? I can delete the awesome project, etc. But now it's your turn. Create a new repo on GitHub, online first, and delete it if you want. Excellent question. I think I will repeat this. I forget to tell. Git overall is a way to version your controls. There are different ways. One of them is OneDrive. If you put your files on a OneDrive, they will be stored somewhere. There is actually automatically backed up. Git and OneDrive, for example, don't like each other, right? And it will be double versioning, which is not good. So in general, don't put any project which are version controlled by Git, for example, in OneDrive, right? Put them somewhere else, because then it will actually cause a lot of issues, because it will try to sync things up if you don't want. Because we are recording our changes ourselves. We have full control over the changes instead of OneDrive, which is automatically doing it kind of for you. That's why, and overall, they quite often also don't like the pathing. So there could be some issues, actually, if you do that. Some people do that. Some people do both, double. I would suggest not to do it, because there is no need. You're hopefully doing everything by yourself using the Git commands. Sorry, I've muted. Sorry, my bad. OK, that's much better. So let's wait. Paulo, hopefully accept. That should be email from GitHub. OK, you will accept. You can refresh. Still not. OK, I will not wait. I decided, oh, it was a mistake. I'm deleting. Cool, and it's gone, right? So he can't now accept. But now you can play this with your partner or people around you, make a new stupid repo, and add people to it and try removing it. Has anyone managed to do so? Yeah? OK. I think you get the understanding of how this works. You can do it later. I will a little bit push on time, because we still have an hour left, and I want to get to more complicated stuff. OK. So something we discussed how we now know how to create a local repo on your computer, commit changes, and push it up. We also know how we can create first on remote, and now we need to do something else. If it's only on remote and not on our computer, we need to do clone. It's kind of a weird word. I don't know. I don't like it. But they call it cloning, which is taking a remote repo and put it to your computer. It's the same kind as downloading the file to your computer, right? You can theoretically clone any repo which is public on GitHub. It doesn't have to be yours. It could be anyone's, right? You still only will download it. You can't. Then you can add it on your computer. You can't change it on the remote. If it's your own, then it will be automatically connected and you can pull and push. If it's someone else, it will just download and there is nothing you can do. It's actually very simple. Again, in GitHub Desktop, there will be the file cloning repository in VS Code. You will do command palette if you do with everything, Ctrl-Shift-P, and you will write clone. And in command line, it's git clone, and then name owner repo dot and where do you want to put it, right? So I will do it right now. I will go into GitHub Desktop. I will clone a repo. So I will do file, please watch then do. Clone repo. If you want your own repo, then I can actually just start writing and it will find out all repos. These are my repos. I will do version control playground, and I will put it here. I think, is it there? I'm not sure if I already did it or not. No, it's not there. Okay. And so I selected this one, and I will clone. It will take a little bit, and now it is on mine. I can now show an explorer. It is there, right? It's on my computer. It's very simple. Theoretically, you can the other way around it for people who wants to do it with the command line. So I will show you in the VS Code. Is Ctrl-Shift-P, and it's write clone. Clone, if you can spell. Clone, right? Git clone, exactly. And this is this, and you can clone from GitHub, and it's the same. You can start writing, and it will find out your repos. With the command line, it's a little bit more difficult, as seen in the presentation. You need to write lots of the stuff, as you do with command line. Now, clone any repo. You can clone my repo. You can clone the repo with the presentation. You can clone whatever you found on GitHub. You can clone it. Or you can create the repo which you created on GitHub first. You can now clone it to your computer. Sorry again? Clone it if you want to change it locally, yes. So I'll show you. So if you want to clone someone else's work, right? I will go to GitHub and I will find, I don't know, I will do ggplots. This is a package. This is a package which I'm using for R programming, for example, and I want to clone it to my computer. I will click code, copy. This is the github./owner, which is tidyverse/ggplot, which is the name of the repo, .git. And if I go to here and I will file clone repo, I will put it there. Can't find. What? Is it just like this? What? Oh, URL, sorry. You need to click. GitHub.com will be your own, I forget. URL is anything you have. You can find on the internet, and I will clone. It will be a little bit longer because it's kind of big, and your internet is not very great. Now it's going. So, and it will slowly do it. So I can clone anything from GitHub which is publicly available using the URL, which is github.com/owner/repo.git. That's the address, the Git address. Okay? It will take some time. Now we are killing the Wi-Fi. We are all downloading things, right? Have you managed to clone, or who is done? Who's cloned anything? Raise your hand. Okay. Okay, I will push a little bit forward. I will do the one last thing, and then we will have a break. Okay? So, something which will happen at some point in your career is a merge conflict. Merge conflict is happening when the same people edit the same file at the same time, meaning that there is this yellow person, he will do a change, push in between, another person will change the file differently, but didn't pull the changes. He doesn't have the most recent things, and he will try to push as well. And then the Git will be confused because there will be two realities, and he will not know which is the correct one. So what he will get merge conflict. This is how it looks in command line. You will see something similar in IDE, in like VS Code or GitHub, whatever. And if you read what it's actually saying, it says errors failed to push some references to the name of the repo. Updates were rejected because the remote contains work that you do not have locally. As we said, someone else pushed stuff, you don't have it. It's usually caused by another repository pushing to the same ref. If you want to first integrate the remote changes, git pull before pushing again, right? This is what it's suggesting, which is a good suggestion. How to avoid this, right? This is an annoying thing. Commit often, we discussed. Push, pull regularly. Work in small steps. That's really my suggestion. If you kind of did reasonable amount of work, commit and push, right? That's kind of my suggestion. Don't wait all day or all week. I tell it to my students always, like, at least once a day, at the end of the day, push stuff to GitHub, right? Organize your code or whatever if you do coding, if you do Python, in small modules or scripts. The more you have them, there is smaller chance that you will mess up something, right? If you are, for example, writing a visualization script, someone else working on data wrangling script will not cause any issues because you're not editing the same file at the same time, right? That's where I generally talk about R because I'm R data scientist. So it's the same thing. I'm splitting the work into small scripts, small incremental scripts, and we can work more collaboratively. But mostly, how to avoid merge conflicts is using branches, which we're going to be talking after the break. Just to show you, if you have merge conflict, what will actually happen in your file? The Git will automatically edit your file. Imagine this is a file which has an issue. And the first line is fine. If you have questions, please. This is the file. This is a line within a file. But Git will automatically add this weird, I call them, how do you call them? Like decorations is the word. Decoration, which is kind of this hat. We will have this hat. Then these lines, these equals, and then another, this branch A. What does it mean? How you can read it? This is very annoying, by the way, this pointer. Is that it doesn't know which is the second line. It's pretty sure about the first line. The first line is if you have a question, and then one person committed, open an issue, another person committed, ask your questions, right, in ERC. I don't know what does it mean, but basically now your local computer is telling you, I don't know which should be the second line. I don't know which commit is more important. It's called merge conflict. We will explain why it's merge. So how you fix it? You will delete everything you don't want in that file, including the decorations. We decided the reality if we want correctly is the ask your questions. You will delete any unwanted, you will save the file, stage commit again, and done. This is how you solve the merge conflict. It's actually a little bit easier on GitHub. We will show you, and you can completely avoid it with branches. So this is even more difficult to showcase, right? I can do it right now I can actually try. But just to show you how this is done, what we can do, no, this one, we can go back to Awesome Project. And I will also open Awesome Project on my, here as well, repositories, Awesome Project. I will edit this file by a bike. I will add it. I will buy a new bike, save, commit changes. I'm not sure if it can even work. I actually don't know. And here I will do the same. I will open Awesome Project, how to make a bike, and I will write buy a car and save it, right? So there, and now I will commit. I want car. And if I try to commit, it did, and I will push. Ba-da-da-da! Right? There is an issue. Unable to push. because there is something else. So I need to fetch, I need to, oh, fetching is updating your local, what is happening online. I'll fetch. And I don't know actually. And it says, oh, there are one up, one down. And so it says, oh, actually, there is this conflicted one. I can open RStudio. Can I open in Show and Explore? Okay, and here it is, right? It added automatically. This is the problematic file. It doesn't know what to do. If this line is the correct one, I will do what I want. I will delete anything which I don't want. Let's say I want a bike. I keep with the bike, right? I will save. I will go back, and it's actually, oh, it's enough. Continue. I say fine, and I can push, and it's done, right? I resolve the thing. I will not let you do it. You can play with it a little bit with branches, which makes more sense. The last thing which I want to show you before we go to a break, I need to find out my presentation, which is here, is, oops, I did a mistake. You will do mistakes, right? Oops, I did a mistake. Version 8. I committed, but didn't push. I only committed, so only it's on my local. It's not on the remote, right? That's mistake A. In GitHub Desktop, it's very simple. There is undo button. Right? You commit it, and you can undo. It's the same in VS Code. You can do Control-Shift-P, command palette, undo last commit. Very simple. In command line, a little bit more difficult. You need to set git reset, soft, hat, and 1. 1 is how many commits do you want to go back? 1 is 1. If you do 2, it will go back 2, etc. Variant B, oops, I committed and pushed already. That's a bigger problem a little bit. You can click on a commit and press revert commit. I will show you in GitHub Desktop. Again, it's the same in source control, in VS Code. You can revert a commit. In command line, it's even more complicated. You need to do git reset hard. The previous was soft. And SHA is the individual identification of the commit you want to return back to. But I will show it now in GitHub Desktop. Actually, I'm not sure if it's going to work with this one. I will switch to some other project. I can now, this is a committed thing. So I will open and explore. I will do a commit so you can see before editing. I will do secret, I love chocolate. There's a file. Hello? Hello? Mouse? Okay. I will do I don't love chocolate. I actually hate chocolate. And then I need the mouse, please. Can you work? Hello? My mouse is dead. Okay. Cool to know. And now if you go back to GitHub, I can see, oh, there is I love chocolate. I will commit. I will commit to mine. I didn't want to do so. Undo commit. Whew, simple. It will undo the commit. It will not fix the file. Right? If you want to fix the file, you can discard changes. And it will restore whatever changes you do. It will automatically restore the files to the previous version it's known, right? So it gets rid of the changes. If you want to revert the commit, that's a little bit difficult. I will press, and I can hear, I think, revert changes in a commit. Right? I'm not going to do it, but you can. And with that, we will take a break. If you can practice this if you want, but let's take a 5-minute break, and then we will, and if there are questions, I will welcome them. Okay, in the last section of this workshop, I will be talking about branches. And to me, this is where really the Git gets really cool. This is, I think, the strongest feature of all this Git and version control. This is where we got real power. So, what we've seen previously, or I need to put this in, is we know these bubbles, right? We've seen these bubbles. Oh, you will do, this is a state of project. We will do commit, you will do commit, you will do commit. Now, what we can do, we can create branches. Branches are parallel universes, right? If I like, for example, Marvel movies, you've seen lots of them are now parallel universe, right? Or different dimension. which are completely unrelated to our dimension. It could be really nicely summarized in this one, I think, where we have I think it's a squirrel, I don't know. We have a squirrel and we create a new branch, and this will be different reality. In this reality, this squirrel is getting glasses, and then we create a new, different branch, different reality, and in this reality, it's getting a graduation hat. The squirrel with graduation hat and the squirrel with the glasses don't know about each other at all. They're in different universes, then can't interact. They are completely different until we merge them into one reality. We squish the realities back to our, and both of them are true, right? We put them all together. So we need to make a new branch, which is called a new reality, and I'll show it again here. Oh, I didn't fix my mouse. Okay. So you can see it in GitHub Desktop. There's a new button, new branch, which is very simple. In VS Code, again, Control-Shift-P, new branch, command line, git branch, name of the branch. I'll show it how this is done. Hopefully my mouse will work. Maybe. We'll see. Yay, okay. So I will go to GitHub Desktop. I will switch back to my awesome project. You can fetch, nothing changes. So now it's very simple here. You can see I'm on main branch by default. The branch is called main, or previously some of the old ones call it master. I click on branches, create new branch, name it make a cake. It will be make a cake. Again, it cannot have spaces. It can have dashes, and it can have slashes. What is it called? I create. And now I'm on a different branch. I'm on a make a car branch. I can switch back by choosing this one. But let's stay on make a cake. I'm on a make a cake. I will show an explorer, and I will make a new file, which is called cake recipe. I'll make it bigger, sorry. So you can see, this is, oh, it is, okay. Sorry, it's super small. But I make a new file, cake recipe. We see it, oh, it's here, right? I will now open it, and I will say, I need eggs, I need flour. What I need? Flour? Let's make it something weird. Let's put in, I don't know, sausage, a pork, right? This will be a terrible cake, egg pork cake. Oh no, and then if I save it, if I go to this one, I can commit, right? I will commit, create a cake recipe, fine, committing. So I can see, if I go back, oh, there's so cake recipe is there, I'm on this branch. If I now switch back to main, and I look, it's gone, right? Because in the main reality, I've never created the file. I'm in a different reality, right? What I can do, it works both ways. If I'm now on main, and I will create a new, again, text document, and I call it secret. I cannot spell, right? And I will commit, create secret to the main. Secret is there. If I switch to make a cake, secret is gone because it never created in this reality, but cake recipe is there, right? That's because I'm switching between two completely different realities. Switching, we see this. It's sometimes called checkout. Yeah, the question? Yes. They are in the .git folder. For now, right? So what does it mean they are in the Git? So this is complicated, but what does it mean it's in their Git folder? Your computer is just ones and zeros somewhere, right? How you're showing something is somewhere is that your computer showing it this way, right? But the files are both, you're correct, are both stored on your computer somewhere. the Explorer will not show them, right? But the Git, because the Git is kind of pulling the strings what is being shown, right? But if you commit, and if you have the branch on your computer, both of them are there, right? Even though, for example, you can't see them in your Explorer. Again, we see how the switching the line, the switching the in. If you use command line, git checkout, name of the branch, you can switch between the branches the same. I think now it's time for you to make a branch, switch it, commit changes, and you can push it around. Oh, this is something I haven't seen. But here, of course, now, same with commits, same with the branches, they are only living on my local. I now need to actually push this branch to GitHub. And now, if I go in a GitHub, I can see here, there are the branches here. 2 branches, I can switch between branches, main and cake here. Or I can click on branches, there will be all the branches. Cool, you go. Your time. There. So, okay, I'll move on. So, you know, creating branches is cool, but we can do this parallel universes, but it's useless until we can actually put them together, right? Actually use this information in our current reality. It's called merging branch, right? So this is how, this is a scenario. Oh, no, okay, I need to, again. Okay, I need to, this is how it is before. Again, these are the bubbles, they are commit, commit, commit. We created a branch, and we're committing here. Some features, again, this is because lots of the Git and GitHub is for tech bros from Silicon Valley. But here, we now need to put these branches together. We're gonna merge them, put these realities, smash them together. This is done using a thing which is annoyingly called pull request. That was a mistake, the name. It should be merge request. That the logical name of this feature should be merge request, but for some reason they call it pull request, I think. And again, we have a main branch. We create a new one. We will do commit, commit, pull request, and then merge it back. It should be merge request, and we are requesting to merge these branches together. It is also a good place to discuss, as we see. Again, this is the same thing again. Create a branch, add commits, open a pull request. We can discuss and review, I will show you, and then merge and deploy. In our case, just merge. So pull request is a request to merge these branches, and we will do it on GitHub. After you push a new branch, you should have a green button, compare and pull request. I will show you how this is done. This is a terrible resolution, sorry. It is also, I will do this step by step. Okay. Does this work now? Yes. Okay. So if we are on a, not here, I need to delete lots of these. So if we are on my awesome project again, and remember, we pushed a new branch. If you push the new branch, it will automatically kind of detect that there is a new branch called make a cake, and it will suggest create the pull request. You can also do this by looking in branches. No, you can't. You should. It was able to. Okay. Then you can click on pull request, create new pull request, and it's the same thing. But we will click the button, the big one. This is how normally you will do it. And what we can see here, we can see main and make a cake. So this is saying that I'm taking the branch, make a cake, and I'm putting it to the main. Right? This is the direction of the things. Theoretically, you can merge any direction you want or any branch to any branch. Right? Theoretically, but what we want to do, we have this new branch and we want to merge it to the main. It says it's able to merge. Now, there are things which you can say, title and description. This is all the things you've done. Pull request is generally good to describe. It can have multiple commits, so you kind of summarize what you've done overall. So I will say, make a recipe for cake. I can write description. This is a markdown, right? So we can do headings. What? Etc. Right? Which will be typo. Am I making a cake? Question mark? I cannot spell. And we will create new pull request. I think so. So the pull request is now existing. We can see existing pull request here on top in a pull request tab. If you open the tab, we see all pull requests. There could be multiple ones. We have this one which we call make a cake recipe. And again, information, it's open. It was me. Who wants to merge into a main from a cake? So I'm taking the branch which is called make a cake into a main. There's the name of all the things. I can do description. I can also, and you can also see the history of all the commits here. Making a pull request doesn't mean that the branch is over. It is just telling I'm taking this branch into this branch. These branches are both still valid. So what I can do now, actually, I can go into make a cake branch, and I can edit the recipe. I need, how does this flour, like this, maybe, save. And hopefully, yeah. And I will say, add flour. I hope I'm not, and commit. And push, right? Because there's a new commit which I added to the branch, and now if I look at the pull request, it will know. There was the first commit here, but now there's the new commit here, and it's kind of a track of everything we changed to this branch. What you can also do, you can do comments. You can do, hey, this is cool. I can comment on stuff. And I can comment. And again, this will be kind of the thing with the description, which commits were in, some comments from someone else. You can imagine this could be from a collaborator. Right? I can do add someone else, you need to do this. You can, if you have collaborators, right? For example, blah, blah, blah. And can discuss. Overview we can discuss. Okay, it's your turn to create pull request. Make a new branch, push it to the remote, create a pull request. Okay, hopefully you've done the pull request. And now the big thing which some of you already did, but I will do now, is not only we will open the pull request, we are happy with the changes, we can merge them. We want to put these realities together. If I connect my pointer again, then I can also do it. Okay. So, I put a note on Markdown. So if you don't know, Markdown is a way you can write human and computer readable formatting in plain text, and GitHub do understand. There are quite a lot of programs who do this, like Obsidian and Vim, and lots of things now understand Markdown formatting. For example, there is you can read them up, but anything you write in, for example, description of your pull request or in the comments on your pull request, if you write them using Markdown, like hashtag will be first header. If you wrap them in stars, it will be italics, etc. Right? So you can kind of format text to look nicely very easily. So they will understand. So everything on GitHub do use this. So if you know Markdown, you can keep using it. If you don't know Markdown, I recommend learning it. So pull request, overall, it's a tool for review. And that's why the collaboration comes in, right? What I would suggest is you can review suggested changes and tell them something. I already did it. You see, I open pull request. I can now say, hey, Alfredo, do you like these changes? And he will say, good. Or he can say no, etc. Right? So this is kind of a safe way if multiple people are working on the same project together. What I would recommend is create a branch for everything, right? I want to add visualization. I will create new branch visualization, put it there, create pull request, tag, for example, my colleague, hey, I create visualization, do you like them? And she's like, no. Don't do this. In the meantime, I created something else. So we can kind of collaborate before we merging them, before we make them reality, so to kind of prevent, for example, conflicts. It's, in general, I like it, I'm using it a lot for student, right? For student work, if you have students or if you have someone who is in a learning process, that's a great tool because you can say, hey, create a branch, do pull request, I will review the things and let you know, say, hey, good to go, or I don't like this implementation, maybe you need to tweak a little bit, there's a better way if you use this module, etc., etc. So for collaboration, it's cool. I think I will show this. Oh, this is terrible. You can view, I will, on someone else's pull request on your own, I can show. You can view all the things and comment on it. I will do it. Again, terrible. I will be showing you the commenting. I think that's a good tool for lots of you. No? So if we go into my open pull request, I'm not a reviewer, but if I click on file changes, this is a way of overview of all the things we've done. I can submit a review. I can comment on the whole thing, on the whole changes. I can also add pork does not belongs to cake, question mark, comment. There's a, okay, comment. There's a typo, that's fine. And now the owner of this pull request will get notification, and it's also automatically put there that I commented on this one, right? And I can now go back and forth with this person who is responsible for this pull request to do it in a way until we are both satisfied before we merge, right? So especially, you can actually, I haven't seen this, but here there is a panel called reviewers. If there is another person in the repo, you can request the review from this person. We can now request for AI. I'm not going to do it to burn credits, and they will be notified. Hey, this person opened a pull request and requires your yes.
So like the reviewer requests change,
Mm-hmm.
and then how does that change implemented? How to make it simple, how we commit again?
Exactly that. Exactly.
So the branch is still alive.
Yes. The branch is alive until we merge them. We haven't merged them yet, right? So exactly. So they will notify. You can. I skipped over it, but if you're interested, we are a little bit short in time. Is you can approve or request changes, right? I was not requested. If you are requested as a reviewer, you will have these two things. Approve means good to go, you can merge. Request changes is no. Right? So if this is hard to simulate again, but let's try AI. Right? So AI is now, and here, there's one pending review, right? I will see if I have different reviewer, if they have done the review, if they haven't done, I will see this. But AI, I don't know how long will it take. I'm waiting for request. See? Doesn't matter, right? So as you said, the changes you need to do if you're not using some smart AI, but if you're a reviewer, you request, oh, this needs to be changed. And then the person who is actually responsible for this one will have to go, do the changes, commit, and then again, you can re-request review. Now I did changes, look at again, right? So this is very cool, especially in a, I would say, learning environment. It's very cool. But now the main cake, right? Now we want to merge them. Some of you already did it. What can happen is when you try to merge, there will be merge conflict. And this is exactly the same as we see with the before with the merge conflicts, but now this is much easier to solve because you can just click on the resolve conflict. You will open the file. Sorry about the colors, but it will be the same. We will see, oh, we know this, right? There's the decorations, and it doesn't know which line belongs there. We will delete anything we don't want, and we will commit. And it's, I think, nicer. It can be the same, and it's online. It's when you're doing the pull requesting, right? So if I will try to do it, sorry, on my, here, I'm happy. Let's not wait for, oh, actually I did. This pull request adds a new cake, so he will actually do AI review. Cool, thank you. And we can, here is the button. Here is the magic button, merge pull requests. Automatically, it will kind of say that it merged pull request one from this branch. And this is the description. You can change it if you want. I will commit merge, and now it's there, right? So if we now go into the code, if you remember, we have, hello? Oh, we haven't pushed. Right? We have merged from the conflict. Perfect. Cool. So if you remember, I actually created secret and cake on 2 different realities. Right? If you go back to example, and both cake recipe and secret are both there. If you go to commit history, you'll now see there's the create cake recipe, create secret, add floor, all of this there, and there is a new one which is merging the pull request. That's actually the new commit will automatically create when you merge 2 branches, which says, oh, he's actually put these 2 together. I'm not sure if yeah, go ahead and do that, merge. Some of you did, so you didn't. Yeah.
So to be sure, so the merge also the committed changes after the pull request, right?
No, good question. So the merge will do at that point of time. It will take whatever commits are in the branch you are trying to merge into and put them there. If you then, and you shouldn't do this, if you then commit again to the same branch, you need to create a new pull request. But generally, what I would do, generally you should delete your branch after merging them. The cycle is create a branch for a new thing you want to do the thing, suggest pull request, ask for a view if you want, if you work alone, merge, delete branch, create a new branch, and this kind of cycle of safety working, because you can also experiment, right? Because imagine, oh, I actually thought about redoing this whole analysis from this point of view. I will create a new branch, tried to doing it, and then decided, it's bad. So I will never merge that branch, I will just delete the branch, or keep the branch there, and I will continue on my main, because it was a dead end, right? So this is also very nice, actually, space for experimentation, or not being afraid to change things in your project because for, I don't know, for massive changes, right? If you're doing it safely on a branch, doesn't matter because your reality is still intact, right? Your main will be always there. Who has merged their branch? Okay, I'll wait. That's been everything. So the GitHub, as you noticed, there's much more functionality which you haven't touched at all. Right? There's so much things for project management, for collaboration, etc. So the thing you see today, I try to put as much together as possible in this short time. And there's lots of things you can do. Right? There's project management, collaboration, dissemination. You can share actually your code, automation. You can create small automatic processes, etc. And in addition, I also do presentation on these topics, like clean code, reproducibleness, etc. But maybe next time. So for now, this has been everything from me. If more questions, I will still walking around you, but that is kind of, I think, 5 minutes before the time. Thank you very much.